Hey guys! I feel like it's been forever since I did a video. Oh, looks like it's been forever since I brushed my hair too! You want to see how I did my hair this morning? It looks like this. Okay, lesson 9, here we go. So excited. I'm actually recording. I'm not going to mess this one up today, but even if I did, I'd keep going. Do you remember when we were reviewing for our celebration of learning and I taught you this like secret undercover thing that if you ran into anyone that works for Eureka, you denied knowing about? Well, that thing we're actually doing today. So we no longer have to live in fear that we're going to be shaken down by a Eureka investigator. We're doing that thing. We're finding equivalent fractions numerically. Yes, let's do this. Is this 9? Whoop whoop. You guys, yeah, I know. This is all we're doing. We are finding common denominators numerically. No longer are we having to live a paranoid lifestyle. So we're adding 3/8 and 3/7 together. You guys immediately recognize that those denominators are not the same. 8 and 7 are not the same number, and I will tell you, yes, you are correct. So there's a lot of different ways you can find a common denominator. Let's go ahead and use the way that I think will be most straightforward for this particular problem. We're going to multiply the denominators together. 8 and 7 are denominators, those downstairs numbers. 8 times 7 is 56. This is my favorite multiplication expression because we have 5, 6, 7, 8. Very cool. So a common denominator, one of the many, many common denominators between 8 and 7 is 56. So we're going to rewrite 3/8 and 3/7 as equivalent fractions. Equivalent, of course, is a fancy word for equal. An equivalent fraction for 3/8, but this time the denominator is going to be 56. We're going to find an equivalent fraction to 3/7. This time around, yep, denominator is 56. So this is how we're going to do that. And I kind of went through this I went through this very, very quickly when we were reviewing for a celebration of learning. So this time I'm going to be a little bit more intentional, shall we say. Okay, so what number did we multiply 8 by to make it a 56? Spoiler alert, the number's right over there. Oh yeah, we multiplied 8 times 7 to get 56. And you guys know the deep, dark history of numerators and denominators. They get insanely jealous of one another. So if you're going to multiply 8 by 7, you better multiply 3 by 7 or else there's going to be problems. So 8 times 7 is 56. 3 times 7, my friends, 21. Thank you. Over here. Now we have to think, what magic number did I multiply 7 by to make it a 56? Oh, right. I multiplied it by an 8. Okay, great. So if we're going to multiply 7 by 8, you better multiply 3 by 8 or else there's going to be problems. What is 3 times 8? It's 24. So now, you guys, what we have equivalent fractions. 21/56 is equivalent to 3/8. 24/56 is equivalent to 3/7. Now, we can add because we have common denominators. We could not add these numbers together when we had a denominator of 8 and 7. It's like adding an apple together with an orange. That doesn't make any sense. But if you have an apple and an orange, if you find a common denominator, which is fruit, then we're in business. Okay, so our denominator is going to remain 56. Now we have to figure out, what in the world is 21 plus 24? Let's see if I can challenge myself and add horizontally. 20 plus 24, nailing it. 1 plus 1, I'm sorry, nope, not nailing it. 1 plus 4, 5. Booyah, 45/56. Kind of a complicated fraction. Here's where we're going to add another layer of awesomeness. I'm going to look at these numbers and I'm going to think, can I simplify them? Can I divide the top number and the bottom number by something that is the same to kind of simplify their lives? I'm really considering this. I'm thinking about, I can divide 45 by 5. I can divide it by 9. Ooh. I can divide 45 by 9. Same thing, jealousy. If you divide 45 by 9, you better divide 56 by 9. No, I don't want to divide 56 by 9. 56 is not easily divisible by 9. You nut. I'm thinking that maybe this is lowest form. 56 can be divided, and this is the struggle of a mathematician. 56 can be divided by 2. It can be divided by 7. It can be divided by 8. I think this is actually lowest form. Okay, final answer. I'm going for it. I tried to simplify 45, 56, but I'm going to say that that's lowest form. If any of you math whizzes out there can find something that I can divide the top by and the bottom by to simplify this, go for it. But I think that's all she wrote for that one. I'll continue thinking about it though. Let's move on. Yeah, so right now this is where we're going to stop. 45, 56. Yeah, we're good. Sometimes fractions are complicated. Life is complicated. That's okay. We're not scared. Okay, so that's our first one. Let's see if I can move over to the second one. Let's look at 4/9 plus 4/7. That's what sound fractions make when they move, shift. Why is my color working? You guys are immediately recognizing that 9 and 7 are not the same number. And I would say, you are correct. We need to find a common denominator between 9 and 7. Let's go ahead and use the same strategy as we did over here. One way to find a common denominator between two numbers is to simply multiply those numbers together. The denominators, that is. 9 times 7, 63. So a common denominator between 9 and 7 is 63. So I'm going to rewrite these fractions with a new denominator of 63. So now we have to consider, what is our new numerator? Well, 9 was multiplied by 7 to form a 63. You guys know whatever's going on downstairs has to go on upstairs, or else things are going to get weird. 4 times 7, 28. Let's go ahead. So 28 63rds is equivalent to 4/9. 4/7, I need a common equivalent fraction with a denominator of 63 so that we can add these two incredible fractions together. Well, 7 was multiplied by what number to make a 63? Well, 7 was multiplied by 9, remember this, to make a 63. If we're multiplying 7 by 9, yes, you guys are catching on. You better multiply 4 by 9. 4 times 9 is 36. Now we have two equivalent fractions with the same denominator, which means we can proceed with the addition. 28 plus 36, I could really try to do that in my head, but I feel more comfortable stacking these up vertically, and there is no shame in that. 28 plus 36, 8 plus 6 is 14. Bring our 1 and our tens place value over. 1 plus 2 is 3. 3 plus 3 is 6. Beautiful. So what we have here, you guys, is 64 63rds. Oh, but Miss C, that's an improper fraction. I can simplify this fraction. Indeed, you can. You guys are recognizing that 64 is larger than 63. Improper fraction alert. Let's go ahead and simplify this fraction so that they are not embarrassed to be seen in public. I can decompose 64 into 63 plus 1. So we can rewrite 64 63rds as 63 63rds plus 1 63rd. Do you guys remember working on that in lesson 1 and 2? We decomposed 64 into 63 plus 1, and then we rewrote 64 63rds as 63 63rds plus 1 63rd. From here, you guys are so clever, you're already thinking, oh, another form of 63 63rds is 1. So our mixed number version of that improper fraction, our simplified version is 1 and 1 63rd. Cool beans. Let's check out another we'll look at 2 more expressions here, guys. Okay, let's check out a couple more here, guys. Back to that first problem that I was doing. It was like 3/8 plus something. I think the final answer was 45/56, if I recall. It was the first one, and I was trying to simplify it, but it wasn't really working out. That was the final answer. Yeah, we are all good. 45 and 56 do not have anything in common that we could divide them both by to simplify that number. So yeah, it looks like a fairly complicated fraction, but hey, it's no big deal. You're a great fraction. Simplify it in your simplest form, even though usually when you see double digit over double digit, you think you can work with it. No, that's just how you're going to be. Live your best life, 45/56. E, 1/3 plus 7/5. 3 and 5 are not the same number. I know, Mrs. C, that in order to add these together, we have to transform both of these fractions into equivalent fractions, sideways equal signs, so that we can add them together. Let's go ahead and continue using the strategy for finding a common denominator that we have been for the first two examples. And let's just multiply 3 times 5 because it is so easy. 3 times 5 is 15. So a common denominator between 3 and 5 is 15. So we're going to find equivalent fractions for both of these original fractions that now have a denominator of 15. You guys, I think, are becoming pretty comfortable with the fact that, okay, so we multiplied 3 by 5 in the bottom. Same's happening upstairs. 1 times 5 is 5. Over here, we multiplied 5 times 3 to get 15. And so the same is going to happen with our 7. 7 times 3 is 21. Now we can just add 5 plus 21, I can do that, is 26 over 15. Improper fraction alert. Let's go ahead and simplify this. Let's get it to a mixed number in lowest terms. We can do that by dismantling or disjointing or decomposing this 26 into 15. I'm pulling a 15 out because that's the denominator, and I know 15/15 is equal to 1 whole. If I take 15 away from 26, what do we have left? Ain't no shame in doing a little side subtraction. 11. So I can decompose 26 into 15 and 11, which means I can go ahead and rewrite 26/15 as 15/15, 15/15 plus, then we have 11/15 left over. 15/15 plus 11/15 is 26/15, but in improper fraction form. Let's go ahead and rename 15/15 as whole number 1, and then we have 11/15 left over. So final answer here, you brilliant geniuses, 1 and 11/15. Gosh, I'm kind of sad that this is, we're getting to our final problem. I've been really enjoying this work. This is great because we are going to use a new strategy, not a new, but another strategy for finding a common denominator. One strategy is to multiply the denominators together. That's part 1 of our secret word. What is the first strategy that we're using to find a common denominator? Well, the first strategy we're using, Mrs. C, is just to multiply the denominators together. That's our first strategy. The second strategy is going to use skip counting. We're going to skip count with each denominator here on the side until we find a number that they share in common. We don't want to multiply 8 times 12. I mean, we could. We're absolutely capable of that. But that denominator is going to get quite hefty. And it's a Tuesday. I don't want to deal with hefty denominators today. I saw enough of those yesterday. I think our Grayson had a denominator of like 250 yesterday, and that almost broke my brain. So I want to keep things as simple as possible in life and in math. So another strategy, a second strategy, is to skip count. And you're just going to have to use your best judgment, depending on what the denominators are, when you figure out which strategy you're using, whether you multiply the denominators or you skip counting. Okay, so skip counting I love because I imagine skipping around, counting by 8s. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. I'm going to hang there. Now I'm going to skip count by 12. 12 times 1 is 12. 12 times 2 is 24. Oh, bingo. We've got a common number. I'm going to circle them with that kind of crooked, not a rectangle, Mrs. C, sort of a crooked oval. And I found a common denominator. Okay, we're in business. This is going to require some thoughts. So our common denominator is 24. What do I multiply 8 by in order to transform it into a 24? Well, it's 8 times 1, 2, 3. We multiplied 8 by 3, or we can multiply 8 by 3 to get 24. You guys know, same rules apply. Whatever you multiply your denominator by, you must multiply your numerator by, or else we're going to have problems. 5 times 3. So we have 8 times 3 and 5 times 3. What is 5 times 3? It is 15. Cool. Over here, 24. So we're not multiplying, we're not necessarily multiplying by the opposite denominator any longer. I'm trying to just shift this over. Cool. Now we have to think, okay, so 24 is my common denominator. We started with 12. What do we multiply 12 by to result in a product of 24? Well, 1, 2. 2 12s make up a 24. So we multiply 12 by 2 to make a 24. And I think you guys are one step ahead of me. That also means that you have to multiply 7 by 2, which is 14. Now we have 2 equivalent fractions to 5/8 and 7/12. These equivalent fractions, thank goodness, have common denominators, or this same denominator. Now we can just carry through with our addition. 15 plus 14, 29. Improper fraction alert. Nobody panic. We can handle this. Let's decompose 29 into 24 because that's the denominator. We can pull out a whole number 1 out of 29. If I take 24 out of 29, what do I have left? 5. Okay, cool. Let's rewrite 29 24ths as 24 24ths. And we're rewriting this, meaning we're just writing this in a different form. Plus 5 24ths. 24 24ths plus 5 24ths is equal to 29 24ths. This is just going to get us in a mixed number, a more precise version of this improper fraction. 24 24ths we can rewrite as whole number 1. So we will be looking at 1 and 5 24ths. Final answer. Very cool stuff, you guys. Secret word again. What are the 2 strategies that we're using right now in lesson 9 to find a common denominator? We have 1 strategy here, and then we have 1 strategy here. You guys are awesome. Thank you for being awesome. Please continue being awesome.